Hi, in this video, we're going to talk about concept about force along a line. This is one of the most essential topics in statics because you're going to use this over and over. What is force along a line? Essentially, it's you are giving a force magnitude. For example, they said, okay, this is a force here, and the magnitude, let's see, 500 Newton. Okay. And then they said this force is along this line. And in order to define a line, they're going to give 2 points, right? Let's see if its first point's M, the second point's N. And those are the 2 points. And they said this force is along the line between from M to N. So initial and final point are important because that gives us the direction. So then we have a hat over it, which means has a direction. That defines this force, 500 Newton, is connecting starting from M and ends with A. That's how the notation or convention comes about to writing this force along line. And our goal for force along line is being able to find out its Fx, Fy, and Fz. Basically, their IJK term, right? And you might have thought about, okay, in the previous video, we're talking about decomposed force to Fx, Fy, Z. We just need to know the force magnitude, which we have here, 500 Newton. And then we just need to know 3 angles, this force regarded to X, Y, Z axis. But sometimes when you have a force in 3-dimensional, in order to measure those 3 angles, is extremely tedious. So we're actually going to have to think outside the box. What are the other ways to do? And that's how we're going to approach this problem. They tell us it's connecting from M to N. That's what's given. And for example, here I would just come up some random number for M. M is 1, Y is, let's say, 3, and Z is 10. Then N coordinate. So I'm writing down the coordinate of those 2 points. And so N is going to be, let's see, 5. And Y coordinate is going to be 12. And Z coordinate is going to be 4, for example. So those are the 2 coordinates given. How do we get into this? Write down the force in a 3D vector form. So first thing I want you to review what you learned about in math. If you were given 2 points, we are going to figure out this position vector. Position vector is defined from starting point M ends with final point Mn. It has a direction, and in order to do that, for example, from M to N, this position vector, we know it's going to be the final coordinate minus initial coordinate, right? So general form is going to be x2 minus x1, and that's going to be our I term, and the y coordinate difference, and our z coordinate difference. That's how we write down this position vector. So for this particular example, start with M, ends with N. So we're going to use final N minus initial M. 5 minus 1, 12 minus 3 for our y coordinate, and our z coordinate, J. Z coordinate is going to be 4 minus 10. That's our K. Then we'll have 4i plus 9j minus 6k. That's our position vector, defining from M to N. Okay, that gives us a sense of direction, right, from M to N. But if I were to ask you, how long is from M to N? What's the distance? Or what's the distance from M to N? And that's essentially tell us the magnitude of this position vector. So Mn, now this time we don't have a hat because it's a magnitude. It's a distance. between those 2 points. And we know when you have a vector 3D, in order to find the magnitude, you figure out their x component 4 square plus y component 9 square plus negative 6 square. That's going to give us the distance from M to N. So quickly put in the calculator. Let's see what we got. So I have answer as 11.53. And this should be able to take a unit. So here I'm gonna go back, consider this is all in meter, okay? So that will gonna be 11.53 meter from M to N. So now we know the position vector in 3D form in this first step. We also figured out the distance from M to N. Now the third thing we're gonna figure it out. If we were trying to find a unit vector, lambda, this unit vector is going to try to describe this from M to N. So that unit vector tells us a direction from M to N, but has magnitude of only 1. Okay, so that gave us the direction of this force direction from M to N, but with magnitude of only 1. Because let's go back to step 1. The position vector give us the direction already, and step 2 give us the distance. So how do we get lambda? We're going to get the position vector Mn divide by its own magnitude. In that situation, you only get the direction and the magnitude will be 1. Okay, so with that logic, we can go ahead and substitute our Mn with a hat, which is a vector, position vector, 4i plus 9j minus 6k. And divided by its magnitude, which is 11.53. Then we can continue to simplify to I, j, k term. So it's going to be 4 over 11.53. J term is going to be plus 9 over 11.53. And k will be negative 6 over 11.53. Then we can go ahead and find ijk term. So quickly put it into my calculator. So we have 3.345. I'm sorry, 3.347. Okay, for I term. Now let's look at j term. 9 over 11.53. And hopefully you get 0.78. And for the last term is negative 6 over 11.53. We will have negative 52. Okay, so knowing that, you get a unit vector for the direction. Now we are almost there, right? Because our goal is force along a line. The force is going to have a magnitude, which at the very beginning it's given. It's 500 Newton. And force is going to have a direction, and you already have it. This unit vector is going to give us the direction. So at the end, we just need to combine those two together. So this force with a hat, since as it's a vector, it's going to be equal to F without a hat. That's going to be our force magnitude. Just to be aware, this is not the magnitude for the position vector. It's not the distance, it's a force magnitude. This force magnitude is 500 Newton. Okay, and then it's going to times this direction. Direction is defined by this unit vector, and lambda mn from M to N with a magnitude of 1. So in that situation, we can go ahead and put it in here. 500 Newton. It's going to times this direction unit vectors 0.347 I plus 0.78 j minus 0.52 k. And here I'm actually going to challenge you. I'm going to challenge you to see if you can find this unit vector if it is magnitude of 1. How do we do that? You are going to go 0.347 square plus 0.78 square plus negative 0.52 square. See if that's indeed give you 1. If you did, I mean your logic is right? So now let's go back to this last step. Once you know the magnitude of force and then you know the direction, and we are so close to get to our goal, just think about our goal. Our goal is to find fx, fy, fz, which is ijk component. So our I term is going to be 500 times 0.347. And our j term will be 500 times 0.78j. And our k term 500 times 0.52k. So putting them together, we will have our I term. 500 times 0.347 will have answer as 173.5. Then our j term is going to be 500 times 0.78. That gives us 390. The last term, 500 times 0.52 is going to be equal to negative 260k. Alright. Excuse the ruckus we have at home with the dog. Sorry. So anyway, so you got our force along a line. The first problem. You write down the fx, fy, fz, k term. So how would that? So that's going to be your fx. This will be your fy, and this is going to be our fz. So that's it for this problem. And now, using this problem, we're going to go from specific to general. How do you look for force along a line? This is a quick recap. First step, if we are trying to find force from A to B, what we need to do, we need to find A and B coordinate. Why do we need to find the AB coordinate? Because that's help us finding the position vector. AB, position vector. And be aware, how do we do that? Final minus the initial coordinate. Okay. Then the next step is we're going to find AB without a hat. We're going to find the magnitude, the distance connecting from A to B. Then once we know that together, we know we can find the lambda AB. That's going to be our position vector AB over the distance AB. Then we can go ahead figure out our last step, which is FAB is going to be equal to F, this force magnitude without a hat, times your lambda AB, which is lambda AB, or you can write down FAB times AB position vector over AB. So that's all. All right, hopefully this is helpful. I'll see you next time. Bye.